Equally as important as describing the center of a distribution or data set is describing how spread out the data is. In this lesson, we will describe one very popular and important way to do this. First, let's consider the most basic way to describe the spread of the data. That is to simply subtract the minimum from the maximum. So for our pulse rate data, the range is 92 minus 91 minus 52, or 39 beats per minute. You'll have to admit calculating the range is easy. The problem is it's not very reliable. If there is an outlier, the result would be much different. Suppose a student was present that had a pulse rate of 110. Then the range would not be 39, but would be 58. So we need a more reliable statistic to measure the spread of the data. Let me also note that a common mistake is to quote the range as an interval. People say the range is 52 to 91. In statistics, the range is a single number. It is the difference between the maximum and the minimum, in this case 39 beats per minute. So on the way to defining this better statistic to measure the spread of the data, we take a step back and think about how to provide a little bit better description of the data than simply quoting the median. The median cuts the data in half. 50% is on either side of the median. Well, let's go a step further. Let's cut each half in half again. We will call the median of the lower half the first quartile and give it the symbol Q1. We will call the median of the upper half the third quartile and give it the symbol Q3. So now what we now have is three numbers, Q1, the median, and Q3, that split the data into four equal parts. That's why they're called quartiles. Next, we define the interquartile range as the difference between the third quartile and the first quartile. Since Q1 and Q3 mark off the middle 50% of the data, what the interquartile range measures is the spread of the middle 50% of the data. In so doing, it avoids all outliers and hence is a reliable measure of spread. So let's go back to our now familiar pulse rate data. Previously, we found the median to be 72. Now, when the median is part of the data set, not the average of the two middle values, we include the median in both the lower half of the data and the upper half of the data. So notice when I list both halves, the 72, or the median, is included in both. So each half of the data has 12 data values. So if we apply the rule for finding the median, we find that the median of each half occurs at the 13 divided by 2, or the 6.5 location. So to find both Q1 and Q3, we have to average the 6th and 7th observation. So if we count 1, 2, 3, 4, 5, here's the 6th and 7th, here's the 6th and 7th. Q1 is the average of 68 and 70, or 69, and Q3 is the average of 88 and 78, so Q3 is 83. That means that the interquartile range is the difference between 83 and 69. The interquartile range in this example is 14 beats per minute. This is the spread of the middle 50% of the data. Before leaving the concept of the interquartile range, we consider how it is affected by outliers. So I have changed the previously low data value of 52 to 40. A pulse rate of 40 is much lower than the other data values, so it's an outlier on the low side. Notice, however, that when computing Q1 of the first quartile, Q1 is still the average of 68 and 70, so Q1 remains the same at 69 beats per minute. So it's important to realize that the interquartile range is resistant to outliers. So if you have a data set that is skewed, either because it has high or low outliers, the IQR, the interquartile range, is the best measure of spread to quote because it is not impacted by outliers.